Alright guys, so I wanted to do a continuation of precipitation types. And in the previous video we looked at different forms of precipitation. Most people when they think of precipitation they think of rain, maybe snow, but probably not so much hail, sleet, and freezing rain like we talked about before. So at the end of that video we were looking at, there was an image of some y-axes. I'm going to draw them on paper. So here I have a y-axis, and what we're going to do is draw essentially a profile of the atmosphere. And remember that our weather largely occurs in the troposphere, the lower layer of the atmosphere. This is where our water vapor is. Once you get above the troposphere and into the stratosphere, we really don't have essentially any water vapor to work with. And without water vapor, we can't really have any kind of weather, right? So we need water in order to have weather, to form clouds, to have any kind of precipitation in the first place. So we're talking about the troposphere. Now we'll label our vertical axis altitude. So I'll just put ALT for altitude. The exact numbers don't really matter too much here. Okay, then over here, we're going to have 0 degrees. Now, assuming we're doing this in Fahrenheit, the freezing point of water is 32, so I'm going to label that because it's an important number, of course. And then we have warmer temperatures going this way. I'm just going to write warmer. The exact temperatures don't really matter. Now let's start out with rain. So I'm going to label this rain. Well, rain could occur at temperatures over 32 or below 32. But by the time either the ice crystal or the drop of water reaches the ground, it certainly is going to be warm and probably over 32 degrees. So let's start out with a low cloud, a cloud that's at a low elevation or low altitude. Well, we know that in the troposphere, it of course gets colder as we go further aloft. So near the surface, it's going to be warmer. And let's say we have a cloud that's relatively low. Well, as the water falls from the cloud, it's going to come down and it's going to get warmer. And as that water comes down, it warms up and it hits the ground as rain, of course. Sometimes we see this happen with ice crystals. Even in the summertime, the cloud might be so high that we get ice crystals even in July. They're below freezing, but by the time they reach the ground, they will have crossed this 32 point and they will have melted. So we might have a low cloud or a lower altitude cloud where it was rain the entire time. Or we could have ice crystals, even in the summer, even in July, August, that transition to rain somewhere high in the altitude in the atmosphere and come to the ground as rain. And that's rain. Fairly straightforward, although sometimes people don't realize that rain might have its start as ice crystals or basically snow, but melt on the way down. And that's something that we see year-round. Let's take a look at snow. So now we're going to do something like this. Same type of setup. We're going to have 0, 32. It's going to get warmer. And here we'll do altitude. Again. Now when we're talking about snow, well, we don't get above 32 degrees. At least not normally. So we have ice crystals falling from a cloud, and they stay as ice crystals the entire way down. They never cross over that 32 mark. There are some exceptions where maybe they could just dip to like 33, 34 degrees and then get cold again, but that's a special case. So most of the time they're going to stay below 32 degrees, and they're going to remain as ice crystals the entire way down. And that would be snow. So rain and snow, fairly simple. Now let's take a look at sleet. So what we'll do is we'll draw a similar type y-axis like this. I'll label it sleet. We'll have 0 here, 32 degrees. I'll label this altitude. And in the case of sleet, we either have ice crystals or maybe rain. But as the precipitation falls down through the atmosphere, it crosses this 32 line and it warms up. And it either stays as liquid water, or maybe we have ice crystals, basically snow. But then once it crosses 32, it melts and transitions to rain. But then something interesting happens. That rain cools off again. And before it hits the ground, it crosses back below freezing again. It freezes before it hits the ground. And we have these ice pellets we call sleet. This is kind of interesting, actually, because what it means is normally, in a normal situation, it gets colder as we increase altitude. The higher up we go, the colder it gets, assuming we're in the troposphere, and again, all weather happens in the troposphere. In this situation, it's different, though. As we go up in altitude, it gets warmer, and then it gets colder. This is a situation called a temperature inversion, and this means that we have a layer of warm air. And this is called a temperature inversion. Inversion means upside down. Something inverted means it's flipped over. And the idea here is, well, instead of it getting colder as we go up and up and up, well, we have this warm layer in between. This could be due to what's called an occluded front, which is something to learn about in the occluded and stationary fronts video that you'll watch later. And there's other things that could cause this too. So we have this kind of warm pocket in the mid-levels of the atmosphere. And as the snow comes down, it hits that warm pocket of air, melts, refreezes before it hits the ground. And we see little pellets coming down as ice, or little ice pellets we call sleet. And just like I mentioned in the other video, some adults or people, oftentimes adults will say this is hail. But again, hail comes out of severe weather, thunderstorms, and is not a product of snow melting and refreezing and so on. So let's take a look at the last one. We'll take a look now at freezing rain. Hail forms in a very different way. Hail has to do with updrafts and thunderstorms, and basically a drop of water getting thrown up and down within the thunderstorm, freezing, and then as it falls, water freezes onto its surface, and then it gets pushed back up, and it basically gets thrown up and down within the storm over and over and over again. And each time it comes down, it picks up a little water, and then it freezes onto that little droplet of water, and the ice particle gets larger and larger as we go through this, what's called accretion. Water accumulates on the ice. That's a different process. Let's talk about freezing rain now. Okay, so now we have freezing rain. Very similar to sleet in the way that it forms. The only thing that's different is just the temperature profile is just slightly in a different spot. And oftentimes what we see is them occurring in the same storm. We might switch from freezing rain for a while to sleet, back to freezing rain. That's very common. So I'm going to put my 0 here, 32 here. It's going to get warmer as we go this way. Forgot to do that up here. And by the way, I'd like you to write this down on some paper so that you have it. This isn't in your notes, but I'd like you to have this written down. And if you didn't write it down, you could always go back to the beginning of the video and get it. Anyway, let's start out with some snow. So we have snow falling down from the atmosphere. And as that snow comes down, it's warming because we're getting closer to the surface. Now we have a similar temperature inversion type situation as we did with the freezing rain up here. But now what happens is the ground is just below freezing, maybe 31, 30 degrees, something like that, or maybe even right at 32. So we have snow, and then as snow crosses the 32 mark, it transitions over into rain. But before it has time to freeze into ice pellets, like we had with the sleet, it's going to freeze on contact with the ground. So this is a similar situation as sleet, except where it freezes is different. Here, it's crossing into the freezing zone in the atmosphere up above. and it freezes, and we have these water droplets freeze and turn to ice pellets. Here, it doesn't freeze until it makes contact with the ground. So contact with the ground. That's when freezing actually takes place. We also have a temperature inversion here. And again, temperature inversion means it's flipped upside down. Usually as you gain altitude, temperature decreases. Well, here we have a situation where temperature is increasing a little bit. And we have this warm layer of air above. That's called a temperature inversion. And you'll learn that a little more when you do the video on fronts. So that's all for now, and see you next time.